I'm dancing and singing in the exhaust, because you can't. It's a fuel cell. So, Tony.
Yeah.
No internal combustion
No
engine.
internal combustion engine.
And fuel cells up here someplace.
Fuel cells right above our heads now.
And the hydrogen's up there?
Hydrogen's in the front of the bus,
Up
under
here.
that hood there.
Oh, man. So nothing comes out the back but water vapor.
Water vapor, a little bit of steam, clean
Cool.
and healthy.
May I drive?
Yeah, sure. Hop on.
This bus is powered by fuel cells. Instead of storing electricity in batteries, the bus carries its energy in hydrogen. The fuel cells on board convert hydrogen into electricity continuously through a chemical process. The heart of the fuel cell is the proton exchange membrane. Hydrogen is fed on one side and oxygen on the other. The hydrogen separates into protons and electrons. The protons pass through a membrane, while the electrons go through an external circuit as electricity. The protons and electrons then combine with the oxygen, creating water and heat. Fuel cells will operate continuously as long as they have hydrogen and oxygen. By combining single cells together, a fuel cell stack can be made that produces just the right amount of electricity.
It's like riding a bike. No, wait. It's like driving a bus.
That's right. It shouldn't feel any different. Just a lot quieter.
It is
pretty
a lot
smooth.
quieter. People's perception might be that fuel cells, first it's kind of a spooky expression, fuel cells, that this is, decades away. But here's this bus running, right?
That's right. We've got 60 vehicles on the street around the world. There's people hopping on and off fuel cell buses every day. This is certainly something that I'm going to see in my lifetime. Cars all over running on fuel cells.
So how long do you think it is? 10 years?
Yeah, we estimate end of this decade, we will see a significant number of fuel cell cars on the road and starting the commercialization of it to the public.
Let's say the whole world, no, let's say North America, changes from conventional diesel-powered buses or gasoline-powered buses to fuel cell buses. I mean, how much energy will we save?
Let's say they're twice as efficient. You'd be saving half the energy that you would normally have used.
Nothing but water vapor. It's distilled water.
It is.
A toast to the future.
How does it taste?
Like water. It's not bad.
It's terrible. This is one of the worst catastrophes in the world. Oh, the humanity.
She's right. Knowing your chemistry does help you make good decisions about your impact on the environment. Well, class, what is the best fuel for cars? Gasoline-powered cars use octane. Natural gas vehicles use methane. Some fuel cell vehicles use methane, and some use hydrogen. You see, it's all in the molecules. If we keep burning gasoline in our cars, we may be gambling with the environment. See, this is octane. It has 8 carbons and a bunch of hydrogens. When we burn it, we get carbon dioxide and water vapor, but we also get a bunch of heat, lots of heat. But we also get a bunch of other stuff that we don't want, like carbon monoxide, which is poisonous, nitrogen oxides, sulfur oxides, some unburned gasoline, and a bunch of soot. Now this is methane. It's got just 1 carbon and a few hydrogens. When we burn it, we get carbon dioxide and water vapor, but it's much cleaner. We don't get any of this other stuff. So if we could find a way to separate the hydrogen from the carbon. We could use that hydrogen for something else. And we can do that with a reformer in a reformation process. Now, by combining the hydrogen with oxygen in the air in a fuel cell, we can make electricity to run an electric car. See, with hydrogen, our odds are a lot better. This little car is a fuel cell vehicle. This plastic box is the fuel cell. When I throw the switch, it will allow the hydrogen gas to combine with the oxygen to form H2O, water vapor. Now, along with producing water, fuel cells produce electricity. So a fuel cell vehicle is really an electric car with a great battery. When I throw this switch, it'll produce electricity, and off we go. So here's our goal. If we could find a renewable source of hydrogen, we could make getting around a lot cleaner. We're just at the beginning of this technology. There's a hydrogen tank that's running this small cart. See, we can build them just about any scale. The key is finding a source of hydrogen.
The great thing about hydrogen is that it's all around us. It's in plastics, it's in trees, it's in hydrocarbon fuels, certainly a lot of it's in water, but it's always tied up chemically in a chemical compound with something else. We can't get hydrogen, we can't drill a well and pump hydrogen out of the ground. So what you have to do is look for sources that are abundant and extract the hydrogen out of the form that they're in into a purified form that you can use for a device like this.
But you're getting carbon dioxide the same way you get carbon dioxide if you were just to burn it.
Exactly. But because of the efficiency of converting the fuel that you end up with, hydrogen, into either electrical energy or mobile power for a vehicle, a fuel cell can be 2 to 3 times as efficient as an internal combustion engine. We could be domestically secure. We could make all our energy needs in the United States from sources in the United States. We wouldn't be dependent on importing oil from foreign countries.
What's the dream?
The long-term dream is to make all the hydrogen that we need out of renewable resources. Sun, wind, biomass, hydropower, where everyone on the planet can have the power they need. We don't have emissions, we don't have greenhouse gases to worry about. So this is it. This is the dream, the sustainable energy system, power to change the world.
So maybe there is hope. Maybe we will be able to drive more efficient cars and decrease pollution. But even with more efficient cars, there'll be plenty of other problems we have to solve. So I'm up here with Bruce Hafter. We're in the Channel 3 copter here in Phoenix, Arizona. And Bruce, this is your day at the office, right?
Yeah, this is what I do every day. Come up here and fly around Phoenix. When I started flying 8 years ago out of this airport, there was nothing north of this road now. Check it out now. There used to be nothing up there. This used to be the middle of nowhere.
So here we're looking at the desert. There's cacti on the ridgetop and so on, but as we come over the ridge, house after house. So here in Phoenix, we have a textbook example of urban sprawl.